welcome to another Advanced Unity 5 tutorial. Today I'm going to continue on the infinite terrain theme. So this is the infinite terrain we created in the previous tutorial. It has a first person controller in it and it's made out of a whole heap of smart terrain objects which will just keep generating themselves for as long as you can keep walking along. And you can see that going on in the scene here is that these blocks at the back here, or these meshes, delete as you continue to walk forward, and it will create more and more terrain in front of you. I don't know what it is about infinite terrain. It's very sort of compelling. I guess you're curious to keep walking to see what you'll find, but there's actually nothing to find in here except more and more terrain. So what we're going to do now is to try and put some trees into this terrain. Now there's a number of different ways we could do it, using Perlin noise, of course, because we want to make sure that the trees are always in the same place if we return to anywhere in our game world at any time. So we don't want trees that sort of move around. So randomly creating them is a bad idea. Now we've already got Perlin noise running on our smart plane. So if you remember, we created this smart plane and then we created a terrain using this code here. So this will be the code that you've got, and I've changed it only by adding in this line at the top with game object tree. So this will be our tree prefab that we will use to create more trees in the terrain. And if I just go back into here, and if we click on the smart plane that we created, you can see that the tree is exposed in the generate terrain script, and I've added in a tree prefab, which is this one down here, and I got that from the asset store. So I just went to the asset store and searched for trees, and this one came up. This is a nice little pack and it's only $2. Absolute bargain. So I grabbed that and I found one of the trees that I like, and I'm using that prefab. I've moved it up into the highest level of folders into the asset so it's easier to grab. Now if we go back into our generate terrain, which is the code that changes the mesh vertices, we first of all need to figure out where we're going to put these trees. So the easiest thing to do is actually use the Perlin noise that's already being calculated to position the trees, and then use the Y value as some indicator of where those trees are going to go. So let's, for this example, put trees at the highest points on our terrain. Okay. So to find out what they actually are, we can put a debug line in here and just print out this value to see what kind of values we're dealing with. So I'll just save that and then we'll run it. Now once it's run and generated the heights, we actually don't need it to run anymore. We were just interested in finding out what these values are of these mesh. And if you go back through to the top and take a quick scroll through these values, you've got things like 2.3, 1.8. If we go down through, there's even values that go down as low as 0 point something. And the highest value that I've found is around 2.6, at being sort of on the top of all of the hills. Okay, so I'll put my console away down here. Let's go back into the code. So what we want to do is say something like, for each vertex, if the height of it is greater than, let's say, 2.4, then we want to instantiate a tree at that particular point in the terrain. So first of all, we need a vector 3 to calculate the tree position. And the tree position is equal to the X position on the plane plus the plane's actual offset, because not all the planes start at 0, 0. So we need that value for the x position of the tree. Now the tree's height will be at this position that Perlin Noise is calculating, and then its z position will be this value here. All right, so that gives us a position for our tree, and then we can instantiate that tree using the tree prefab we've passed in and putting it at tree pos, and we will just set turn-in.identity in here because we don't want to rotate those trees around at all, and that will then put the trees on those particular vertices for the planes. Okay, so we'll just save that, flip back into Unity, and if we go to our smart plane, just check again that we've put our tree in there, and we press play. And now we will get the height and the trees created. There's an awful lot of trees here, and you can see over in the scene that the trees have been created on the high points of that terrain. So they're on top of the hill. There's quite a lot going on there. And if you want them to be just on the tops of the hills more, we can come back and change this value. If it's greater than 2.6 in the y direction, we should get less trees being generated. Yeah, okay, so if we just go back to the scene here, we can see there's less trees, and we've got some nice trees, and we can actually walk through the valleys where there aren't any trees, also through the trees. Now what you're going to notice as you're walking along is that we're going to get a lag at some point when the new meshes pop into existence ahead of us and the trees themselves have to be generated. There's one, there's another one. Okay, so the more trees you've got, the more problems you're going to have with lag. And in addition, actually just to go back and show you what's going on here again, is that the trees themselves aren't attached to the meshes. So the meshes, when they get deleted behind you, the trees themselves remain. And you can see, if I keep walking this way, over here in the scene view, is that they haven't been destroyed. Now we could fix that problem if we go into our code here and we grab hold of our tree with something like this. So game object t equals that, and then we set the tree's parent for the transform. Whoops, transform dot parent equals this dot transform. That will attach the tree to the smart plane so that when the smart plane gets destroyed, the trees will go with it. If I save that and switch back and run, you'll now see as we walk along and watch in the scene as each plane starts to disappear from the furthest reaches, that the trees will also disappear with it. But we still have this lagging problem of it creating this plane and the trees. So this is not the ideal situation. So what you really want to do is use a method that's called object pooling. And what object pooling is to create all of your assets at the beginning of the game when the game first is initialized, and then just keep reusing the same assets over and over again. Instantiating and destroying inside your game loop is a really bad idea. Some of the earliest game pooling is like in the old Space Invader arcade games where you would shoot bullets at the Space Invaders as they come down, you might only have an arsenal of like 5 bullets. And if you've got 5 bullets in the air, you won't be able to shoot any more bullets until those other bullets get destroyed off the screen. So they actually go back into a pool. So what we're going to do is we're going to create a pool of trees and keep using the same trees over and over again by just moving them around onto the landscape where they're needed, which means we won't be destroying and creating trees constantly throughout this whole exercise, which should get rid of that lag problem. So the first thing we need to do is remove the trees that we've added to our smart mesh, which we can get rid of here. So we'll get rid of our prefab that we're bringing in, and we're also going to get rid of this part of the code inside our for statement that actually generates the trees, because they're now going to be created elsewhere. Okay, so I'll save that. Now let's just flick back to Unity, and if we run it, just to check, we've got no trees. Great. Now we're going to create this tree pool. So let's make an empty game object, and we will call that tree pool, like that. And to generate our trees right at the beginning of the program when it runs, we need a new script. So I've created one here called tree pool, which you can also create, which is a C# file. And if we open that up, this is what I've got in here so far. So we've got our tree pool class. Inside it, I've got a integer which will set how many trees to produce at the beginning of the game. This will be the entire pool. Currently it's set at 100, which we will probably find is quite small once we start trying to put trees all over our terrain. We then need this exposed public variable for our tree prefab so that we can create 100 of them from that. And then we generate an array of trees, and this will hold all of our tree objects that have been created. Right, so inside the start function, the first thing we do is set our array to be the size of num trees so that we've got enough memory allocated for those. And then we loop through each of those 100 positions in that array, and we set it to a tree prefab. So we create a tree. Now, all of the trees that are getting created in this pool are going to 0, 0, 0 in the environment, and I'm not rotating them whatsoever. Then they're being set all to be inactive because we're not using them yet. So we're creating them, but we're making them invisible with this line here. Right, so you want to save that code and then attach it to our tree pool object. You'll see you've got an exposed tree prefab, so that's where our tree prefab is going to go into there. And then when we run this, it will create 100 trees as well as our landscape. So there's our landscape, and in the hierarchy you can see the 100 trees that have been created, and they're all inactive. They will be situated at 0, 0, 0. Now we could actually just go to one and turn it on. This one's going to be below the landscape. There it is. So there's one tree that has been created at 0, 0, 0, and all of the 100 trees, they're all underneath that. So they're now ready to be used by the smart terrains, which can then access that array and go, oh, is there any trees available? Can I have some? And then put them on the terrain. And then when they're finished, they can put them back. So let's work on that part of the code now. Okay, so now what we need to do is to make those trees in our tree pool available to our smart planes so that they can use them on the surface. So back in our tree pool code, we need to make the array of trees static, and that will also require that you make the number of trees a static variable as well. By making something static, if you didn't know, what it does is it tells the compiler that this object is going to exist pretty much forever, and it's going to be static, so it's not going to change. It's going to be in the same place in memory for the whole time the program is running, and therefore it is placed in the same place in memory, and that means you can access it really easily from other scripts without all of the get component, get attached script, and all that sort of code mess. So we want these trees to exist the whole time, so we make this static as well as that. Now we're going to also create a new function inside of this tree pool class, and it's called getTree. And this function is also static, and it's a public function so that our smart planes can access this pool and say, get me a tree. And what getTree is doing, this function, is it's looping through its pool of trees, and it's looking for any that aren't currently active. So if we're not an active tree, then we're going to return that tree. Otherwise, if we get all the way through this loop and then we found no available trees, that means they've all been used by the smart plane, then we'll return a null. So we're saying, no, I don't have any trees available at this time. And this will get us some trees. So you need to add this function into the tree pool, as well as setting these values up here to static variables and a static array there. Right, so we'll just save that one. Now, in order to use this getTree function, our smart plane code, which is our getTerrain, is going to, at first, at the very top, we're going to create an array in the form of a list, because the terrain needs to keep track of the trees that it owns. So each plane has a list of trees that has been assigned to it. It needs to know that list of trees that it has so that when it's destroyed, it can let go of those trees and make them available in the pool again. Now, in order to use this list construct for C#, you need to include this collections generic library at the top of your code. Right, so we've got this array or list called myTrees, and we've initialized it like this. Okay, so it'll currently be empty when we start. Now we're going to go back and add a little code that looks slightly familiar as to when we added those trees the first time around. We have an if vertices y is greater than 2.6. So we're testing for the height thing again in order to throw a tree on the top of the hills. Now, if a vertex is higher than 2.6, we're going to create this new game object called new tree. And we're going to assign it the tree that our pool gives us. Now, if there's a tree there, new tree will be pointing at an actual tree. If there's nothing left in the pool, we'll get null returned. So remember that getTree function we just looked at. So then we say if the new tree is not null, so we did get a tree from the pool, we're going to construct the position of that tree. Now this is the same code we used before when we were instantiating trees by hand onto those vertex positions. Our new tree's position will be set to the position we just calculated, and then we're going to turn the tree on. So we'll use set active equals true, which will make the tree visible. Then we're going to add our tree into the myTrees list that belongs to this particular plane. Right, so this bit here is the new code to add and to generate terrain, as well as the list and this library up here. Okay, so if we save this and go back to our Unity and run it, it's going to create the planes and it's going to use up our pool of trees. And you can see over in the hierarchy, these trees are now active because they're not grayed out. And we can't see any trees around us in the game view, but have a look what's going on over here in the scene. If we zoom in on these trees, I'll just double click on one to make it a bit easier. You can see where the 100 trees went. They're all here. These first few planes that were generated gobbled up all of our trees, and there were none left for the rest of the terrain, so it hasn't used any. Now, we did discuss in the previous tutorial that the number of planes around the player is probably a little bit generous. I think, what did we went like a radius of 10, which is quite a lot, because if you look in this view here, you can't really see right to the edge, and you probably don't need 10 tiles off in one direction, and therefore you can actually make this a bit smaller, the number of these, and possibly increase the pool of trees so that we get some more. So let's just try that. Now, remember the landscape itself is generated with this landscape and the generate infinite code, which is here. And our number of tiles, okay, I was wrong. So it's 5 in each direction, which is giving us a radius of 5, which has a 10 by 10 world that we living in. Okay, so let's take that down to 3, which won't give us such a big terrain. Let's save it and run that. Okay, that's a bit better. We get a few more trees going on here. At least this expanding out, because remember, actually each plane is 10 by 10 vertices on each one, so it's going to use up a lot of trees really, really quickly. So you can either lift up the height at which a tree is generated. You could also randomly consider whether you're going to put a tree at that particular height or not, or you can make the pool of trees bigger. So if we do all of those things, let's go and make our pool bigger. So in here we've got 100 trees. Let's make 1,000. That's not going to be too onerous on the system running for this pool. And the trees I've used are for mobile use, so they're quite low poly anyway. So let's save that. And then we'll just also go to our, not generate infinite, we want our terrain, generate terrain here, where we're selecting the size, height, of where the trees are going. So let's say if it's greater than 2.6 and random.range between 0 and 100 is less than 10, then we're giving it a 10% chance that if it is higher than that, that will generate a tree. So in that way, we've increased our tree pool, and we've also sort of spread the trees out a little bit randomly. Now, again, that's not going to work on an infinite terrain, which I've just recalled, because it's a random placement of the tree. The next time you come back and that plane is generated again after you've wandered off into the distance and come back, the trees will be in a different place. But let's just have a look at what it does anyway. So when we run it, now we can see that those trees, look, they've spread right across for us. So that's quite nice. And the randomness gives us a little bit of interest in there as well. So possibly instead of using a pure random function, we could just use another Perl and noise function in there to ensure that we get the same sequence of random numbers again when we're generating those trees. So just for consistency, I'm going to get rid of this random range because it's not going to work with an infinite terrain. And run it. And you can see that the trees have immediately bunched up again on that height. Yeah, okay, so we'll fix that with another Perl and noise function. Right, so back in the generate terrain code where I had that random.range before, I've replaced that with this here. So I'm using a Perl and noise again, and I'm going to get it using our vertex X and Z positions. we still need some kind of reference point to use with Perl and noise so that we know when we go back to the same spot on our map that we're still using the same, generating the same Perl and noise value every time. But you don't necessarily want it to match the same Perl and noise that you've generated the height with. So in this case, what I'm doing, I've just added 5, so I'm offsetting it by 5 in this case and dividing it by 10. And then multiplying the whole value up of the Perl and noise by 10, and then checking that it's greater than 4.6. So that will be then used in combination with the height of the map being greater than 2.6 in order to generate a tree. So what that means is not every position on the map over 2.6 will have a tree on it, and that will allow us to spread out the use of those 1,000 trees. Now, if we put that in and go back and play it, we'll now see, and you can see it in the scene. Okay, it is a bit sparse. You can play around with that Perl and noise to get something you're after. It doesn't look too bad if you're on the ground wandering around. And I've also reduced this map again to like a 3x3 radius. And, you know, you get some sort of interesting little clusters of trees here and there. And you can always mix it up by adding different sorts of trees at different heights as well. Another thing you'll see on this map, if we just come down here and just have a look at the base of these trees, because they're being positioned at the vertex position, sometimes a few of them, like this one just here where my mouse is pointing, is sitting above the terrain. In this particular case, what you could do back when you're creating the tree on the plane at the height, this is its height here, you could just reduce it by a little bit in order to bury the tree into the ground a bit more so that you can't see where it's joining the terrain. But we won't worry about that for now. Okay, so we've gone through and we've got trees out of the pool as we've needed them. Now we need to destroy the trees after, well, sorry, not destroy the trees, put the trees back into the pool and set them to inactive when the smart plane itself gets destroyed. So to do that, in our generate terrain script, which is attached to our smart planes, we are going to add in an onDestroy function so that when the planes are destroyed behind the player as you're moving forward, any trees that were assigned to that particular plane are set to inactive and that plane's list of trees is cleared. I guess we don't really need to clear the list of trees because they're going to be destroyed with the plane itself, though I guess I've sort of accounted for it here to release the memory. Which you might not necessarily need. Anyway, you do need this onDestroy function, which I've added in the generate terrain. So this is after the start function that actually gets the tree from the pool and sets it up on the mesh. After the start function, this is the bracket that ends the start function, we have an onDestroy. This is a built-in Unity function that will get run when the object is destroyed, which in this case is the smart plane. Now we're going to loop through our list of trees, which we do with this .count value, which will be the size of our list. So we loop through it. Then I've got if the tree at that position is not equal to null, then we're going to set that particular tree to false. That will turn it off, which will make it available in the pool again. So the tree itself never left the pool array. It just got its activity turned on or off so that it could be used. So it turns it back off so that when we use that getTree function back in the tree pool, it will grab this tree again. After we've looped through it, we then clear the array. And now, as I said, you probably don't need to do this because this is happening as the plane is being destroyed and this myTrees won't exist for this plane anymore. Now, the other little thing I've added in here is this testing for whether the tree itself is actually existing, which seems a little odd because you imagine the tree would be existing because we don't destroy any of the trees. But what I found, if you don't have this line in here, when you stop playing the game, it throws a lot of errors about trying to do something to a game object that has been destroyed. This is because of the way things get cleaned up when you stop playing something. So you could live with those errors, I guess, because it's not really affecting you if they're happening when the game's turning itself off. But I've just got in here for a bit of neatness. Right, okay, so that's the only function we need to do to release the trees back to the availability in the pool. So if we save that, and let's go back and run this. Now, you'll be able to see things popping into view because I made the terrain smaller and I didn't adjust where the fog was. So if we go for a walk, notice in the scene here too that the terrain will start to disappear and the new terrain will be generated. And the trees will also snap into view. I'm actually very close to the edge here, so you can see it very clearly. Oh, too steep. I might have to jump up there. Now, we could increase the size of our map again back to 5 and maybe put a few more trees into the pool so we have access to them. Oh, I can't get up that hill either. But you're getting the idea, okay? So now you can see that the pool of trees is just being reused over and over again, and there's no lag whatsoever. Now, if we were really smart, what we would do is put each of the smart planes into a pool as well and create all of the ones we need at the beginning and then just keep reusing them over and over again and move them instead of this instantiate and destroy. Because at the beginning, remember I said that an instantiate and destroy inside your game loop is really a bad idea and you shouldn't do it. We've done it here in a lot of the other tutorials that we've already done because it's easy and it makes sense when you're doing it. So if you're mocking something up, as we've done here, then that works fine because it's really nice and quick to do. And then you don't have to bother about setting up lists and making sure things are active and inactive. And I'm actually quite a lazy coder, so I don't tend to make the pools immediately until I come up to a problem like we had with these trees. So I would encourage you to use pooling if you're after really good performance, and it would be a good idea for the Minecraft example too. Anyway, that's how to put trees onto your terrain. Not only trees, you could put other things on the terrain as well. As I said, you could have different types of vegetation or rocks at different heights. You can vary what's going on in the terrain. You could make your player character much smaller so the terrain was sort of huge, and then vary the size of the trees. And also you can put buildings at different heights as well. So I hope that added a little bit more insight about Perl and noise, especially how powerful the concept of Perl and noise is. And yeah, good luck with your Unity, and I will talk to you in the next tutorial.